Hello, I am Professor Sachin Sambhaji Patil. I welcome all of you for this session. So in this session we are going to see 80386 microprocessor architecture. Okay. So welcome to all of you for this session. So 80386 microprocessor architecture, which consists of the main three. These are the important blocks. We can see there are 6 blocks we can see here: bus interface unit, code prefetch unit, instruction decoder unit, execution unit, segmentation unit, and paging unit. Okay, so bus interface unit, which consists of the address bus and data bus, and this, as we know, address bus is pointing to the memory location. Okay, address bus in the case of the 80386 microprocessor, it is 32, so 2 raised to 32, 4 GB of memory locations it can access. Also 80386 microprocessor is having 32 data lines and it is bidirectional. We can send data and we can receive data. Okay, so address bus is pointing to the memory locations, data bus is carrying data, it is bidirectional, data bus is bidirectional, address bus is unidirectional. So whatever the fetching of the code in program from the memory location take place, it goes to the code prefetch unit. Code prefetch unit, it consists of the prefetch unit and prefetch queue. Okay, queue is having the first in first out. Okay, so that is the pattern. We can see FI FO. Okay, so first in means whatever the first instruction is coming here, okay, that first instruction will be fetch, decode, execute. And 80386 microprocessor is having 3-stage pipelining architecture. So 3-stage pipelining means what? The first instruction fetching take place, then decoding of first instruction, and then execution. So while first instruction decoding take place, fetching of next instruction take place. Okay, so when there is execution of first instruction take place, decoding of second instruction take place. Okay, and there is fetching of next instruction, third instruction will be take place. So there is fetch, decode, execution is there. It's possible in this 80386 3-stage pipeline. There is 3-stage pipelining. Okay, so one is fetch, decode, execute, and there is simultaneously there is 3 instructions can be executed at one time. So then it is given to the instruction decoder unit. The instruction decoder unit is decoding the instruction and it is given to the instruction queue. After decoding of instruction, the processor is understanding the how many byte of the instruction and how the execution will take place. It is given to the ALU, arithmetic logic unit, barrel shifter, and register files. So there are 8 general purpose registers. Okay, accumulator register, extended accumulator register, extended B register, extended C register, and extended D register. Also there is a, we can say, stack segment. Okay, that is a stack pointer, base pointer is there, stack pointer, base pointer, source index, and destination index. So in this way there is registers are available, that is 8 general purpose 32-bit registers. Okay, so this register file is there, and this is given to segmentation and paging. So segmentation unit and paging unit, these are the part of memory management unit, MMU. Okay, so it is given to the further. So actually this 80386 architecture is actually, if you see, there is a MMU is available, memory management unit. So this is not available in 80386. So that is a limitation of 80386 microprocessor. So 80386 microprocessor is having BIU, bus interface unit, and execution unit. Okay, and 80386 microprocessor is having bus interface unit, execution unit, plus memory management unit. So memory management unit is not available in 80386 microprocessor. So that is a limitation of 80386 microprocessor. That is a 8086 microprocessor. Sorry. So 8086 microprocessor is having bus interface unit and execution unit. Okay, so 80386 microprocessor is having bus interface unit, execution unit, and memory management unit. So that is the advantage of 80386 microprocessor. Okay, so if you see further, 8086 microprocessor is having limitation. 8086 microprocessor is not having memory management unit, but 80386 microprocessor is having memory management unit. Okay, so if you see further, this is again architecture having the same blocks: bus interface unit, code prefetch unit, instruction decode unit, Then execution unit consists of ALU, register, multiply, divide, barrel shifters. Okay, is given to the memory management unit. It consists of the adder, registers, limit. Okay, these are the different blocks. Okay, so this arrow is indicating bidirectional. This bus is there bidirectional, and how the fetching of instruction take place goes to the code free page, is going to the execution unit, then going to the memory management unit. So these are the important blocks of 80386 microprocessor. Okay, so we can see further these are actually 6 functional blocks are there, important. Okay, so this already we discussed. Then bus interface unit, actually it consists of the it is set of the bus. Okay, the whatever the fetching of code in data take place from memory. So bus interface unit actually it is connected to the memory and IOs. IO means input output devices. It is connected to memory. Okay, so memory it is there 2:32, 4 GB of size of memory, and IO devices is there. So based on internal request for fetching instructions and transferring data from code free page unit. So this 80386 architecture is generating address, data, and control signals. So these are very important buses: address bus, data bus, control bus. Address bus 32, 2:32, 4 GB size of memory. Data bus 32, bidirectional, and control signals are also available. Read write. Okay, read write are the control signals. Then code free page unit. Actually, this code free page unit is a free page instruction when the bus interface unit is not executing. Okay, and this instruction after fetching is going to the decoder. Instruction decoding take place. Next is there instruction decoder unit. Actually, there is a important is there FIFO, first in first out. Whatever instruction decoding is there, it will be take place as per the whatever the instruction stored in the instruction queue. Instruction queue is following the first in first out pattern. Okay, first in first out. First instruction is coming, so that instruction will be executed. Okay, and it will be first out. The second instruction coming, that will be executed, and it will be out. Okay, so in this way. So execution unit consists of execution unit processes the instruction from the instructions queue. Okay, the instruction queue, and it will be given to the, it contains control unit of the data and also protection test unit. Control unit actually it consists of the multiply, divide, effective address calculations. Okay, 32-bit ALU is there, means, and if ALU is 32 bits means data bus also 32-bit. Okay, and registers are also 32-bit. 8 general purpose registers are available. Okay, 64-bit barrel shifter is there, and this data unit is there, carries the out data operations. Protection unit is very important. Protection unit is checks the segmentation violation under the control of microcodes. Segmentation unit, actually segmentation unit and paging unit, these are the important blocks of the memory management unit. Okay, so just remember CPU. Okay, CPU is generating the logical address. Okay, then this logical address converting into the linear address. Okay, with the help of segmentation. So segmentation is converting logical address to linear address, and this linear address converting into physical address with the help of paging. So remember, paging is converting linear address to physical address. Okay, so you remember CPU, central processing unit, is generating logical address. This logical address is converting into the linear address with the help of segmentation. Segmentation means unequal size of partition of memory. Okay, and paging means equal size of partition of memory. So paging is converting linear address to physical address. So there is a concept is there, paging enable, paging disable. So what is happening? So see here, if paging is enabled, whatever linear address is converted to physical address, and paging is disabled, linear address is considered, linear address it is considering as physical address as it is. Okay, so actually there is we seen 3-stage pipelining is there: fetch, decode, execution. So I just will tell 3-stage pipelining means just I will tell here what is happening actually. 3-stage pipelining. See here, this is the three blocks. fetch, decode, execute. Okay, so this we can see. This we can see here, fetch, decode, execute, and like this. Okay, so here when the first instruction there, fetching take place, second instruction decoding, third instruction execution. Okay, when first instruction decoding take place, second instruction fetching take place. When first instruction execution take place, second instruction decoding take place, and when this second instruction execution take place, what is happening? There is a here. This will be decoding of third instruction take place. So it is like this. So see here, first instruction fetching, then decoding. First instruction decoding take place, second instruction fetching. First instruction execution take place, second instruction decoding, and third instruction fetching. Okay, second instruction execution take place, third instruction decoding. Okay, and say and it goes on like this. Okay, so this is called as three-stage pipelining. Three-stage pipelining. So what are the instruction execution is happening? That three-stage pipelining. Whatever the instructions is there, it is execution is there in three stage. Now see, bus interface unit is there, which is the bidirectional data bus, unidirectional address lines, and which consists of BIU, bus interface unit. So code pre-fetch unit is already we have seen, instruction decoding unit, execution unit is there. Then memory management unit, segmentation, paging. So privilege level is one of the concept. Okay, privilege level. There are 4 privilege levels. Privilege level 0, privilege level 1, 2, 3. So privilege level 0, is having the highest priority and is highly secure. Okay. So just to remember what is privilege levels. So privilege levels. So just here, privilege level is having the 0 is having highest priority. Privilege level. Privilege level. So privilege level 0 is having highest priority than privilege level 1. Okay, privilege level 1 is having highest priority than privilege level 2, and it is having highest priority than privilege level 3. Okay, so take a simple example, principal. Okay, highest priority, then HOD is having highest priority than teacher, and is having highest priority than peon. So what is happening? These privilege levels. So see here, what do you mean by this? What are the tasks present in the privilege level 0? Okay, so that cannot be, okay, that task privilege level 0 can access to the any one privilege levels. So because principal is having highest priority than others. Okay, so this can be, principal can be accessible, it can be give commands to the any other. Okay, like this. So privilege level task 0, it can access any other task, data and code of any other privilege level. So privilege level 3, it is lowest priority and it is less secure. So privilege level 3 cannot access to any other privilege level task, code and data. Okay, because privilege level 0 is having highest priority, highly secure. Privilege level 3 is having lowest priority, less secure. So what is happening? The higher level, it can access lower level code and data, but lower level task cannot access higher level code and data. Okay, like this. So privilege level 0 is having highest priority, highly secure, secure is there, and privilege level 3 is having lowest priority, less secure. So paging unit is there, required for memory management, and okay, these are the registers, 8 general purpose registers. Extended accumulator register, extended B register, extended C register, extended D register, 32-bit registers, extended stack pointer, base pointer, source index and destination index. Okay, so these registers are there, 8 general purpose registers of 80386. AX is 16-bit register, AL lower byte, AH higher byte, BL lower byte, BH higher byte, CL lower byte, CH higher byte, DL lower byte, DL, DH higher byte. So this is the 0 to 15 and 15 to 31. So 0 to 31 32-bit registers available.